All right, good morning or good afternoon, depending on where you're calling from. My name is Charlotte, and I want to welcome you to today's Tech Talk, 3 easy improvements in your microservices architecture. We do have a couple of housekeeping items to go over. Everyone will be muted for the Tech Talk, but please type any questions you may have as we go along in the Q&A panel. We'll answer as many as we can at the end of the presentation. We're also recording this Tech Talk session, and it'll be sent to everybody via email following the talk. We're also live streaming this Tech Talk on YouTube, and the video will be made available there as well. Now that we've taken care of that, I want to thank you for joining. It'll be moderated by Vladimir Schreiner and presented by Nicolas Frankel. With that, I'll pass it off to you, Nicolas, to get us started.
Thanks, Shala. Hi, everybody. Thanks to be here. I hope you are safe. I hope you are at home. And today, I want to talk to you about 3 performance improvements in your microservices architecture. Well, to be honest, it will be about any architecture, but since if you put microservices in the title, you get a lot more people into that. I'm Nicolas Frankel. I've been a developer, an architect, a team lead for like nearly 15 years. And since about 2 years, I've become a developer advocate. When I was still doing only tech, I was a consultant. So I've worked in a lot of different companies for a lot of different customers, different domains with different teams. And that is to say that I'm used to enterprise text. So that will be what I will be showing here. I work for a company called Hazelcast, so I hope that you know about Hazelcast you join our Tech Talks. IMDG is our first product. I will talk about it a lot in the coming presentation. You might know also about Hazelcast Jet, which leverages IMDG to do data streaming in memory. So if you don't know about it, I encourage you to have a check. So still, this is microservices. Everybody is doing microservices because, I mean, it makes the world so much better. And this is the definition that is given not by me, but by Martin Fowler, who is a reference in our industry. And this is the bullet points that you need to follow if you want to do microservices. And I would like you to write in the chat if you do the first, if you do microservices, if you achieve the first. So I will just check the chat. So now I need to find where it is in all this stuff. And chat, show chat. So I see no people are writing anything, so I should be very worried. Are there anybody in the talk?
Yeah, Nicolas, we have more than 20 people in the room, so they are just shy.
Okay, yeah, okay, maybe they are shy people.
Yeah, maybe tell a French joke.
No, all French jokes shouldn't be broadcast on YouTube. None of them. So this is a Hazelcast sponsored talk, so I won't tell any French joke. Okay, so I will do without that. In general, if you are doing microservices, you handle all the tech points. So in general, yes, you create your services. You have you don't do like in the past with ESB or SOE or whatever. You have like not central governance. Every service has its own data store. It's SQL data store, is a NoSQL data store. In general, because you start having a lot of microservices, then you do automation because you cannot do without. With a bit of experience in general, you start designing for failure because when you have been burned 1 or twice, then you start thinking about that. And of course, this allows you to design not upfront, but like to migrate your design according to the context. Now, the before last bullet point is a bit harder, is you organize around business capabilities. That might not be always the case, but let's forget about it. In general, when we go to the last point, product or project, then like in a room full of 100 people doing microservices, you might find perhaps 2 or 3 really having products. And the difference between a product and a project is both have a start date, but the product has no end date, and the project has a set end date, and the budget is allotted from the start date to the end date. In general, there is an issue because, of course, the end date arrives, the project is not finished, we must ask for more money. It doesn't work that well. So if you want to do microservices, you must understand that it's not everything is technical, and we as technical approach it from a technical point of view, but some of it is organizational. And the fact that we decide to have product and not project is now, this is what we must do. And one of the biggest benefits of microservices, where you see in every presentation, is scalability. I used to take the example of an internet e-commerce shop, which is based on microservice. And imagine you have the catalog microservice, which is able to list the items. You have the cart microservice, which allows you to put stuff from the catalog into your cart. And then you have the checkout that does the listing of every item. Then you have the pricing, and then you have finally the payment. And in general, it's a funnel. You might have 100 people browsing the catalog, and at each step you lose some few people. And if you have a monolith and you need to scale because you've got more and more customers coming to you, then the problem is that every one of those features that they get scaled the same way, whereas the payment is not as much used as the catalog one. So you want to scale the catalog feature much more. So if you go to the microservice architecture, then you can have like hundreds of nodes of your catalog application and just 1 or 2 nodes for the payment, because again, they are not very much used. And here is a difference between the diagram on the left and the diagram. So what difference do you see in this diagram from the left and from the right? I will wait that perhaps somebody decided not to be shy anymore. Nothing. Well, thanks for the participation. But in that case, I'm an architect. And actually, there is a big difference. Is on the left, there is a microservice call. And on the right, this is just an API call from inside your JVM. I mean, from an architecture point of view, I don't care about the implementation. It's up to the developers. Now, of course, that's a big joke, because we architects, we like draw boxes and rows, and well, we let the technical people handle that craft. But if you have done any implementation of that stuff, you know that now you start distributed systems. And once you step into the realm of distributed system, you understand this is absolutely not the same. There are tons of differences. Like, just think about the fact that if you do an API call from inside the JVM, you say, I don't know, system out on println, then it will just be inside the JVM an instruction call and it's done. But if you do the same, you ask for logging from a remote system and you do an HTTP request, well, it will be like super slow. And now if you add all those layers of microservices calling each other, then it will get super slow times the number of like steps you make. And here it's even the best case scenario that everything works out as expected. But again, in distributed systems, a lot of things that we know from one single machine is completely wrong. And the first and foremost being the network is reliable. Like you do an API call inside the JVM, it can succeed or it can fail because, yes, there is an exception. But with distributed calls, what happens is there might be something in between. You might make a call and you then get the response. In that case, what the server, the server you made the call to didn't get the request, or perhaps he got the request but couldn't send the response, and you are the one who didn't get the response. And this kind of thinking makes it very, very hard to reason about. This is something that should definitely be printed out in every office. So our previous diagram is not that easy anymore. If we try to get into the real stuff, we have many, many layers between A and B. And if we think about it, it can be network layers, it can be like nodes between A and B, it can be a lot of different abstraction layers. And again, at every step, we add more latency, and at every step, there might be like a problem, there might be a failure that we don't know about. And then finally, because we want the response, this is the real diagram. Now, if you show that to architects, then they might think more about, is that really necessary to do all that stuff just to get scalability? Anyway, let's say we wanted to do that. Now comes the real trade-off. And I must be very, very... In general, in our industry, I've noticed that people tend to reason in black or white. Like, this is the good solution, those are bad solutions. What we are doing right now is, since we don't know whether we will be able to access the data, so in general, what we do in that case is we put a cache. So once we got the data, we cache it. And now the trade-off is we get the data very, very fast because we already have it, but then we might not get the latest data. And so there is a trade-off that everybody in one's own context must decide whether it's a good trade-off or a bad trade-off. Is now you got the data very fast, but it might be stale. And I cannot resist the joke that like this famous quote that there are two hard things in computer science: naming things and off by one errors, which is not made by me. Anyway, if you do caching, and probably everybody among you has already done some caching before. In general, when you are a young engineer and you need a cache, your first reflex is to use a hash map. I mean, I'm guilty as that as well. Hey, we need something, just put it in a cache. Once the stuff is in the map, we can retrieve it from here. No network, already in memory, everything is fine. Well, everything is fine until you realize that a map has no definite size. So basically, its size is bounded, and it can grow and grow and grow and grow. And if your application like needs to put a lot of stuff into this hash map cache and you don't restart, then at some point you probably get an out of memory error. So if you want to avoid that, you should go for a professional solution. Also, there is no eviction strategy. So imagine there is a bounded size, what to do when you want to put more items. Shall we stop from putting more items so we keep the cache as it is, or we shall evict some old items? And then what would be the strategy? Which it would be the most used items which are kept in the cache, or as the freshest or the oldest? I mean, everything is subject to your strategy. So that should be considered. Also, TTL. Like, how long should we keep stale data in the cache? Because the data, as I mentioned, if you are using a cache, data will grow stale at some point. So how long? What's the good time? That should be configurable depending on your cache, and it should be easy to configure it. So for all those reasons, we should use something that is professional, that is enterprise grade. And in Hazelcast, we have this concept of in-memory data grid. You can think about it like a hash map, but it has a benefit of being distributed. As I mentioned, distribution is a hard problem, but we try to solve it for you. And in a microservice architecture, we can have like at least 3 different use cases for caching. The first is database access. So once you get the data from the database, you want to keep it in memory. Now, if you are doing microservices, as I mentioned, HTTP calls are very, very slow. And so they make the chain of microservices call so much slower. So once you get the data, you might want to keep it also to be faster. And finally, it's not about caching and it's not about being fast. It's about being resilient. I will show you how you can use Hazelcast to replicate session data. First, I've been using for a long time Hibernate, like the most used object relational mapping in the Java world. Now, since perhaps a decade, it's a GPA implementation as well. And Hibernate already has caches. There are 2 caches. The first one is called the level 1 cache, and it's implemented by default. I mean, I don't even know how you can rid of it. It's related to the session object. So every time you call Hibernate explicitly, you like have the from the session factory, you retrieve a session, and from the session, you do your stuff. You do your queries, you do your writes, you do your save. The problem is that the session is recreated at each HTTP request in general. So if you are doing web application, every time you get the session factory and from the session factory create a new session object, then you get a new session object with nothing inside the cache. So with the same session, you get the cache for free. With different sessions, you have nothing. So you need to access the database again. And also, if you have multiple nodes and multiple sessions on all nodes, then the cache is completely standalone. Now there is this possibility, this option to configure a second. There are multiple integration available. And how it works? Well, it works like a cache through. So basically, you call to Hibernate, and if the L2 cache doesn't contain the key, he loads it from the database, puts it in the cache, and the next time it contains the key, you ask the value from Hibernate, and it returns it from the L2 cache. And for the writes, once you write something, then it puts it into the cache, and afterwards to the database. So everything is handled automatically for you. Let's have a little demo for that. So here, it uses Spring Data GPA because I'm super lazy and I don't want to write all my queries. It uses Spring Web MVC. I'm using the integration with Hibernate, so I also need Hazelcast. I will be using an in-memory database, but it's a SQL database, so you could be using MySQL, Postgres, Oracle, whatever you want, and it's done. And afterwards, I have a controller that basically stupidly forwards the stuff to a repository. So I can either like read all entities or read one single entity. The repository is based on Spring Data GPI repository. So I don't need to write anything. When I Spring Boot will create the implementation at runtime. Afterwards, I have a bit of data here. So when I start the application, Spring Boot recognizes this file. It will read it and it will execute the SQL so that when I start the application, the H2 database will already be provided with all those entities into the person table. So let's start it. Here, just a word, I'm using the embedded mode of Hazelcast, meaning that I use Hazelcast as a library. And basically, I'm not I cannot scale it independently. So there are two modes in Hazelcast. One is embedded. You add it on the class path as a jar. And then when you scale your application nodes, then you scale your Hazelcast clusters as well. But there is a client server mode as well, where you put all your Hazelcast nodes in different VMs, and so you can scale them independently. But here is a demo, so I want it to be very straightforward, and I didn't know any of this. So I'm running embedded mode. Here, in order to show you that the cache works, I've added the Hibernate statistics. So here, Hibernate has been initialized. Nothing has happened so far. So I have no level 2 cache puts, no hits, no misses, no statements, no nothing. And I will start querying. So I will just like curl http 8080 localhost 8080, and I will curl. I forgot that it's /d. So it works better this way. And now we can check. Here, for example, now since the statistics are enabled, we see that we had one cache miss because the cache was completely cold. Nothing was in the cache. There were no hits. And because after the miss, we did one put. So now if what I told you is true, we should have this entity in the cache. And because I didn't started to be very smart with my configuration, I didn't configure the TTL, I didn't configure eviction, I did configure nothing. So the entity will stay there forever. Better for demos purposes. So if I redo the same query, what will happen is now I have a hit. So I got the data from the cache, and there were no interaction with the database, which normally should be much, much faster. Of course, since I'm using H2, I'm already in memory, but again, this is a demo. Now, I can also ask to have all data. Now I've got all my entities. And because Hazelcast is so much integrated with Hibernate, now if I ask another entity, all those entities should be in the cache already. So the list, I have a hit as well. This will be a difference with what I will show you next. I will stop it. Something that might be interesting to you, you can configure Hazelcast with XML, but you can also configure git log all console. Nope, nope, nope. Yes, here, I forgot here. Checkouts. You can also do that with code. So whether you prefer XML or you prefer YAML, we also have YAML, or you can configure Hazelcast in all those different ways. Okay.
Nicolas,
what I've shown you so far.
I will start with some smart questions since we don't have any in the Q&A. And I again advise anybody with smarter questions than I have to place it in Q&A. And Nicolas can even answer questions in French or German since he's living on the border of Switzerland and France. So my question is, or it's not a question, right? It's more like a topic. So I mean, you explained caching as a tool to kind of remember your frequent queries. So if you are interacting with a system, you are interacting via some RPC, let's remember the answers for a while to save some time. That's quite clear. But to me, the magic always is how to define the the TTL or the eviction. I mean, what is the right configuration to do that, right? I would still rather fancy something more like push-based, so that I don't have to decide whether I will cache the entries for 1 second or 10 seconds, because that really depends on the writer side of that database or repository. Any thoughts here?
Yes. So by default, IMDG lets you define a time to live, and what it's set in time. So basically, let's say we have this pricing microservice, and when the checkout needs to be done, we want to cache the pricing just in case, because the pricing microservice might not be good at the time. So let's say we cache it for 10 seconds or for 10 minutes or for 10 hours. We don't care. That's not very important. The problem is then we have this issue that if you define a window where you will in all cases keep the data, then there are two ways. When you query it again, so you evict it from the cache, you query it again, it does not change. So you make a stupid round trip. You made a useless round trip, which again slows you down. Or on the other side, you keep it, but it has changed. So you keep the wrong data. Is the real problem. As I mentioned before, it's the issue of cache invalidation, which is one of the hardest problems because you don't know what should be the case. So in order to keep a cache that is evergreen, especially if basically the source of truth changes, not like here, imagine that the database has something that writes to it, that changes the entity, and we need to be aware of it. Then there is like smart stuff called change data capture that is, well, I wouldn't say brand new, but quite recent, that lets you capture, get the events, the change events, the updates, or the inserts, wire connect directly to the database, and through the other product that we have called Jets, like directly string the from the database to the cache itself. And then there is no cache eviction from the TTL. Well, there is cache eviction, but there is no TTL. You keep the entities always there. And it's this Jet's job that like keep the database states and the cache state in sync.
Yeah,
Does that answer your question?
Yeah, I mean, I'm asking or bringing this topic intentionally. We had a CDC talk in this tech group like 3 weeks ago, and of course, with the CDC or pushing changes from the repository to the cache, it's technically more elegant, but also more complicated, more complex solution. With pure caching, it's more robust, but you can end up reading stale data. And I just wanted to bring up this topic. What is the right trade-off? And I know that it always depends. I just wanted to ask you, or maybe everybody, if you have any like good experience or a good rule of thumb or any good lessons learned to, yeah, basically influence this decision. So have possibly stale cache or rather have more complex pushed-based ecosystem. Yeah, that was generally it. All right, anyway, let's continue. If anybody has any thoughts, feel free to just share your thoughts in a chat.
I forgot to show you something very important. So thanks for letting me gather my thought. It's how it's configured and the integration with Hazelcast. I wrote no code. So besides the configuration itself, which can be XML or YAML, I just had to use the configuration offered to me by Spring Boot. And this is the only thing that I need to do to actually benefit from this level 2 cache and to put Hazelcast and Hazelcast Hibernate integration on the class path. That is very important, that it's very easy to achieve.
Nicola, we have one live question from Uri in a Q&A related to caching the like security data.
Yes. What's the question?
So the question is, it's ever smart to cache security, security sensitive data like access tokens? I would be somehow worried about increasing possibility of compromising the data.
Of course, you should be very worried. You should be very worried, but again, it depends on the implementation. Like for example, when you are using JWT token, JWT tokens, they are stored on the client. So they could be reused on another browser. So in general, what you do is you encrypt into this token stuff that, for example, the IP address or whatever, that makes the JWT token not reusable in another context. So this could be one way to manage it. So even if you cache like sensitive data, you should always check that it still works. And if it's sensitive in the you also like have access restrictions on the place where they are stored, whether they are stored in the database or they are stored in the cache. So you could have a finer grain authentication and authorization scheme than just allowing everything. Does that answer the question?
That should be your eyes call. I lost your voice for a while, but my understanding was that you are basically suggesting not to cache the security sensitive data in open form, but possibly encrypt it and let the end consumer of the data just decrypt it, and really use the benefit of the cache as a closed data layer, not keeping the data open.
Exactly.
Right?
So what I showed previously is how you could integrate with Hibernate. By doing that, you benefit from some speed improvements, but every now and then you need to get the data out of Hibernate, which is more expensive from a personal performance point of view, synchronized, and it might not fit your use case. So let's assume that you want to be very, very fast, regardless of the downsides. What you could do is you could potentially only interact with Hazelcast cache. So you do the reads from Hazelcast cache, you do the writes to Hazelcast cache. And then underneath, in an async way, the cache would synchronize itself to the database. And in that way, you could be very, very fast and performant. Of course, the downside of it is if your server crashes for any reason, then you lose everything that is in memory, and then your changes won't have been persisted because you are async. So again, there is a trade-off if you want to be fast or if you want to be consistent and to be sure that your data is persisted. This is just another way to use caching with data store, and you can implement it yourself if you are in the context where you require that. I told you already about my e-commerce architecture. I've been working in e-commerce. I love this example because it really fits the real world. So we have all those services or microservices that calls each other, and we want to do some HTTP calls. So we could implement that manually, actually, but there is an API for that. There is something called JCache, and JCache is just a specification, and you can have multiple implementation, and Hazelcast is one of those implementation. Or I would say there is also an integration with Spring, or what we can use, there is something called Spring Cache, and Spring Cache, Hazelcast is also an implementation of it. So let's do some demo and just squeeze, instead of having JCache and Spring, just use directly the integration with Spring Cache because it's much easier to do. I need to get here, Spring Cache. I start the VM. For a second, I was a bit worried. So the thing is, that's the dependency where not done. So now I have an issue because it will be harder for me to show you, to prove it to you. So I will show you how I can prove it to you. I have added another controller, a proxy controller. I have added a new service because, yeah, we love services in Spring. And this caching service, I mean, what it will do is it will cache when you get a person by its ID, it will cache it into a dedicated map. So here, I won't be using, well, it will be used anyway. What I want to show you is how we can cache it through Spring Cache. If I do the same curl as before, done. And now I want to demo to you that it has been put into the cache. There is no easy way to show you the cache, but we have something called Management Center. So if I start the Management Center, and I need to tell you that just up to this point, everything what I showed you was open source and free. Management Center is unfortunately not free. It's part of the enterprise offering. It's this one. And now I must remember, because I always forget the password. Not this one. Here we can see I'm running in embedded mode. I have started one node, so you can see it here. We can see there are two maps, and I don't see the service one, so I should probably do a second call just to make it clear that it should work. Of course, I'm not using the right controller. So this is this one. So there is a reason why it was not loaded. We must wait a bit for it to get refreshed. Now it's been created, it's displayed, and inside this cache, we see there is one entry, we did one get, and of course, because it was not there, we got it from the code. Perhaps I should make it a bit bigger. I don't know how big is your screen. Now, if I query it again, then it should be one entry, two gets, and one hit. And of course, you can continue. So here, I will have a new entry after some time. I will have 3 gets, 2 puts, and 2 entries. Now the question is, if I do that, does it work? No, that's the issue right now, is like, there is no way to put the entire list into the cache. So there is an issue on Spring Framework that was closed with no resolve, because Hibernate, it's easy to do it because Hibernate knows about the key is the primary key and the value is the entity itself. Here, it will be a list of person, and there is no way to know under which ID it will be stored. So it won't be the case. So if you want to put everything into the cache, you need to call every entity directly, or have a job, a jet job that reads from the, let's say, pricing microservice to put it into your data store locally. Final tip. We love stateless. Everybody loves stateless. Stateless makes our world so much easier. The problem with stateless is it's very good in theory. You need some states. And the best example is you are going on an e-commerce shop, you start to put your stuff in your basket, and after some point, you make a new request and everything is gone. That's what would happen if you were like not using this session affinity stuff. So if you go here to do your shopping, in general, you have a web server in front. It gives you like a cookie, and every time you go and ask to do a request, the web server redirects you to the same servlet container or application server. And in this application server, you've got your session data where you store your bus. Is what happens if this first node goes down. If this first node goes down, then your cart is empty again, and you don't want that. And actually, it can not happen. The node will go down at some point. It's not if it goes down, it's when it goes down. So to cope with that issue, we have something called session replication. And of course, the first question is, do we have a standard for session replication? And the problem is there is no standard for session replication. So with the database, we use Hibernate. It's not a standard, but GPA is the standard, but there is a good integration with Hibernate, Hazelcast. On the HTTP call or service call, we've got this JCache or this Spring Cache. They are also pretty good standards. But on the session replication side, we have something called Spring Session. So if you are using Spring Session, that's good. I don't know many companies that are using Spring Sessions. But no worries, Hazelcast can cover you there because we have different integration points. So the first one is filter-based. So you just add a new filter and we will handle session replication. As I mentioned, you can use Spring Session. We have an implementation for Spring Session. Or if you want to directly use Hazelcast session replication, we have direct integration with Tomcat or with Jetty. And whether you run embedded or directly and you deploy a WAR. So this will be my I will need to get here. So I will have a dedicated infrastructure. I will have a Docker Compose file, and this Docker Compose file is composed of a load balancer and 2 nodes. And those 2 nodes, they are the application that I've just shown you. And then I will have this HR proxy in front, and this HR proxy, it's configured so that every even request will go to one node and the odd request will go to the other node. So there is an automatic round robin. So basically, if you have state, you will lose the state because you will go to the other node. And then I have a session data controller. And basically, I'm using the session data controller to manage what I call the session data. And basically, the session data consists of an ID, which is your session ID, and a counter. And this counter, if it gets incremented when it's called. So if I go to one node, it will get me 1. And if I go to the other nodes, the count is still 0 without session replication. So it will tell me 1 again. And if I make a new request, then it will get me 2 because I will be again to the old node, and then it will get me 2. Now what I want is to have session replication. So instead of having 1, 1, 2, 2, I will have 1, 2, 3, 4. How do I configure it? I'm using Tomcat embedded, and it's very, very easy. I have this customizer of Tomcat Servlet web server factory. And then I need to add a context customizer. I create my own Hazelcast session manager. And here, because I'm forcing it to be round robin, I set sticky equal false, which basically disallows some improvements where you are sticky, but it's fine. I just need to remember the name of the map where I store the session data, and it's done. And so let's try it. So I will do Docker compose up. Of course. No, I need to stop this one. Now you can see the node, the first node, the second node has started. Now the load balancer checks that everything is fine. And now I go there and I do local hosts session. So I am on, let's say, the first node or the second node, I don't care. And if I refresh, if session has been replicated, I should get 2. It works. Amazing. And so this is proper session replication. So whatever the node I go to, then I will get the right data. And then your application logic can be stateless because everything is set on the session side. Quick recap. When you go to microservices, it's to be scalable. So be very, very cautious. You will take a performance hit. So as soon as you change your API to an HTTP call, you will lose performance. In order to cope with that, then you can start caching your data and keep your data local. Of course, the problem is stale data. So you need to have a trade-off between, hey, I want the freshest data, but I want to have the data as soon as possible. And we have a lot of integration points. If you are using Java, you are able to use Hazelcast to cache data from database calls. If you are using Hypernet, you are able to do any sort of caching if you are using Jcache or Spring Cache. And you can also have session replication, which are very, very easy to set up. Thanks for your attention. You can read my blog, you can follow me on Twitter, and more importantly, you can all the code that I've shown you is on GitHub, so you can access it and check it and redo everything by yourself. And perhaps now there are some questions. I hope so.
We don't have any live questions so far.
So people were shy so far, so it should be okay, because no questions means either it was the best talk ever, it was like crystal clear, or it was the worst talk ever. And I mean, it's not even a problem of asking questions, it will be a waste of time. So it's always bad when I have no questions, I never know.
You know what, I will actually step in and introduce the topic for next week, which can give people some time to think about questions, if any. So the talk next week is about, it's like a conceptual topic about how to do a snapshot, consistent snapshot of a distributed environment. And it's like a hardcore talk. So whilst Nicolas's talk was very practical, that's gonna be like theoretical, hardcore talk. So if you like reading technical papers, this is gonna be one of those. It's an interesting topic, but it's kind of like a different kind. It's gonna be presented by William Durina, and I'm definitely looking forward. So Nico, we are getting no more questions. So
Okay.
I think it's fair to close the tech talk. Thank you very much for joining it.
Thanks to everybody here.
And looking forward to see all of you next week. Just follow the same channels. By the way, we also, for the first time, played with streaming to YouTube channel. I saw like 8 people following us on live YouTube stream, so hopefully that can work as well going forward. So another step. All right, have a nice week and goodbye.
Bye everybody, stay home, stay